Hello, everyone. Thanks for joining us today as we come together to learn more about deploying apps into Kubernetes. My name is Houssem. I'm the program manager for Microsoft Reactor Abu Dhabi. Microsoft Reactors are hubs for founders and developers to meet and learn and connect to local peers, as well as industry-leading ideas and technology from Microsoft partners and the open source community. It's also home to the Microsoft for Startups program, with a diverse mix of hands-on workshops, expert panels, and community events. There is always something for everyone. Check out our calendar of events on meetup.com and join our coming sessions. Our session today and our speaker is Houssem Dellai. Houssem works for Microsoft as a premier field engineer, focusing on Kubernetes and DevOps. He also was nominated as an MVP, Most Valuable Professional for the past 5 years. He's also very engaged in the community. He speaks in conferences, meetups, and technical discussions. He also shares what he learns on YouTube. You can check out his YouTube channel on Meetup. It's all linked there. And also there are also links to GitHub resources that you need to check out for the session today. Feel free to ask questions during the session. We will have regular stops to answer these questions. And also feel free to tweet about the session and tag us on Microsoft, on Reactor Abu Dhabi, and MSFT Reactor is the Twitter handle. With all that said, I hand over the mic to our speaker today to start the session.
Yeah, thank you, Houssem. Welcome again for this session to learn all about containers on Azure. So let me share my screen. I hope you can see my screen right now. Good. Let me put this in place. Yeah, so thank you for joining again in this session where we learn all about the containers, Kubernetes, CI/CD pipelines, and how to modernize our applications to run our apps on the cloud. So it's going to be all about demo. We'll have lots of demonstrations, lots of code, and lots of configurations. The plan for this session is that we'll take an application, an ASP.NET Core application, then we'll try to dockerize that application. We'll make it run inside a Docker container. So we'll see how to use Dockerfile to create those containers. Then we'll try to connect our application to a database, because web apps always most web apps connects to a database. So we'll see how to add the database and how to connect the two containers to work together. Our third step is to push those containers into a registry. So here we'll see how to use Azure Container Registry to host our containers. Then we'll use Kubernetes, managed Kubernetes instance on Azure, which is the AKS service, in order to deploy our application. So we'll see how to create the cluster, what are the different ways to create the cluster, either using the portal or using the command lines or using Terraform, which is today the preferred way for creating infrastructure on the cloud. And then later we'll see how to create the CI/CD pipelines. So I'll show you some of the pipelines that I have created using Azure DevOps services and also using GitHub Actions. I hope you will find lots of useful information, and I hope you will find it a useful demo for you. So let's get started. For the source code of this application, along with the scripts, it's all available on my GitHub repository on this project called Product Store on Kubernetes. And from here, you can get all the application's source code. Okay. I have already cloned this project on my local machine, so I have it open in my VS Code. And here you can see the all my projects. Let me start by explaining what is the content of this project. So first of all, I have my application here. It's, as I said, it's an ASP.NET Core application. And this means here I have the controllers, I have different pages in my application, I have also products controller, and this application connects to a database. For that, I'm using the products context to retrieve a list of products from my database. And of course, I have the model, which is the product here. Okay, so we'll start now by dockerizing this application. So for now, if I want to run this application on my local machine, I can actually do that. I can go to the command line. From here, I'm opening PowerShell and my MVC app. And from here, we can do the typical commands .NET build to compile the application and then run it in my local machine. But this is using the, let's say, the old approach for running applications. So after .NET build, you can run .NET run to launch the application on my local machine. And with this, in order for me to be able to run this application on my local machine, I need to have the .NET installed on my machine. Okay, so this means I need to install the .NET SDK and also the .NET runtime. And here I have started the application, so it's going to be available on those 4 numbers. So if I go to localhost 5001, from here I can see my application is running, okay? And I can connect to my products database. I can see the different pages, the about, contact, and so on. But now we want to move from this approach to use containers. So here, the first question is, why should I use containers? What is the added value of using containers? So first thing to understand is that containers are enablers for a modern architecture. So what do we mean by that? So now if we're still using the traditional approach for deploying applications, this means in most of the cases we'll need to, let's say if we use virtual machines, for example, we need to provision a virtual machine for each one of my applications. In the case of my application here, it's only a few, let's say 100 or 200 megabytes application. If you want to run this into production, I need to provision a virtual machine that have like 8 gigabytes or 16 gigabytes of memory. And that's a huge machine actually. So I'll pay a lot for that machine just to run my 200 megabytes application. So that's a waste of resources. So we want to optimize the usage of the resources. On one VM, I should be able to run multiple applications, not only one application. But the problem is that that's not recommended today with virtual machines because we don't have that isolation, we don't have enough security for those use cases. But now with containers, we can have that amount of isolation required for those cases. Why? Because when using containers, we'll be running our applications. Each app will run inside a container. And we have that amount of good isolation between those different processes. Another advantage of using containers is that we'll have now our dependencies hosted inside the container. So I'm no longer dependent of that virtual machine. For my application here, I don't need to install the .NET SDK and .NET runtime on the virtual machine, but it's my container who will have all those dependencies packaged together. So when I package or when I deliver a container, that container will have all the dependencies required to run my application. I don't need to add any other dependency to my container. This way I can make sure that my container will run anywhere where I have the Docker runtime. Okay, and that gives us a good amount of portability, because today, with multiple cloud providers, we have our service, Microsoft Azure, uh, Google, and Amazon. In each time you deploy your application on one of those cloud providers, you need to adapt your application to their own, to this specific stuff of their own cloud technology. And now with using containers, you no longer need to take care about those specific dependencies. Your container can run on any cloud provider without worrying about the hosting infrastructure or the configuration of that infrastructure. Great. So that's why we'll have to use containers. So let's see how to Dockerize one application. I see some questions on the chat, or is it that? I hope it's going well. Yep. Okay. So here I have my ASP.NET Core application, and now I want to Dockerize this application. For that, I'll use what we call the Dockerfile. What the Dockerfile is? The Dockerfile is the file that contains all the instructions needed to create a container that can run my application with all the dependencies inside. So here I have an ASP.NET Core application. This means in my container, I should have the dependencies needed to run that ASP.NET Core application. And here, containers provides actually lots of images. Each image is optimized, and it have the required packages to run each type of application. We have images for running Java applications. We have other images for running PHP, for running Python, and for running ASP.NET Core applications. Here I have chosen a container with this name. This one will run my ASP.NET Core application. So, and you note here that I have actually two containers. Let's start by this second one and see what are the different commands used in here. So in this container, or in this image, what I'm doing here is that I'm setting the work directory to be src. This means inside that container, all the following commands will happen inside that src folder. Then I'm copying here the CS proj, which is the project or the file that contains the metadata about my project. I'll copy it, then I'll restore the NuGet packages from there. Okay, NuGet packages are like Maven packages for Java, or NPM packages in React and Angular. Then we'll copy the entire source code for my application to be able later to run the command .NET build to build my application with the release configuration. After that, I'll publish my application, and here publishing means that I'll put all my DLLs inside one folder, so that when I deploy, I'll deploy just that single folder. And then the final step here is to use actually the second image. So for that, we see here base here is an alias to the base written here. So here I'll come back to use my first image. So this means here that I have used the second image to compile the application. For that, you note in the name of the image, it's called SDK. So it have the .NET SDK, which enable me to run the command .NET build. But this image is not optimized for running application in production because it's not, it have lots of components installed. That will make it a bit, it will not be fast. It doesn't have that amount of performance required to run production application. For that, we are using another image optimized for production, which is this first image here. So we use the second image to compile and generate the package, and then we'll copy those packages into the production image. That's what we are doing by the copy operation here. We are copying from the second image to the first image. Then on the second image, I have my application, my DLLs already there, but the application is not started. So how to start it? Here we are using the entry point. Okay, this is the way to start the application. And at the end, I should have my application already running on that second container. So let's see now how to run this file to generate the Docker container. For that, I'll switch to my command line. Here I'm this, and let's make sure that I'm inside the MVC folder where I have my application. I'm already there. So now I'll go to run my Docker file. So I'll use the command docker build. And in this command, I'm passing as an argument the Docker file. Okay, this is the name of this Docker file that will be used with the command docker build. Okay, docker build is what we use to build the image. It means this will generate the image for me. That image will have this name by default. So here we'll see this later. This is the name of my container registry. And then I have the name of my container and the version of that container. The version is what we call the tag. Okay, and then the dot at the end is to say from the current context. It means from inside this MVC app folder. Let's run that and see what will happen here. So here, first of all, I have actually Docker installed on my machine. If you don't have it yet installed, you can go to docker.com and from there install it on your Windows, Mac, or Linux machine. It works on all those OS systems. I have already started it. So here it's taking my Docker file and it's trying to run all the settings, all the instructions line by line. So you see here, in each time, it's trying to accomplish one operation in that Docker file. And at the end, it generated successfully the container, which is called here ACR Stack Azure Web App 1.0. Cool. We have the container generated. Now let's run this container. But to do that, again, I'll use the command docker run. Copied this command ahead of time, and I'm using this nice feature in Windows by using the Windows and the V button. So here, docker run. This is the command I use to launch my application. Okay, so the configuration for this command is that we should do the port mapping. Okay, so here I'm doing the mapping between those two port numbers. Let me show you one thing here. We didn't talk about this. The expose. Here we are actually exposing the port number from inside the Docker container itself. We want to say that inside the container, because we can expose multiple port numbers, and we are exposing particularly the port 80 to say, if you want to access your application inside the container, you should go through the port 80. But I will access that container from another virtual machine, and then I want to access the application from outside. So I need to access at first the port number for the virtual machine, and that will redirect me to the port number of the application inside the container. So here, absolutely, we need to do a port number mapping. And I'm using here, I should be able to access my application on the port number 555. Cool. Now, after that, I tell it what container to start. Okay, and in my case, it's the one that I have already created. Running enter will give me this long ID for that container. And now it means, because I have specified here -d, I'm running this command in the detached mode. So it will launch the container, then it will give me the control back to the PowerShell window. So my application is now running on the port 555. Let's go to check that port number. Go to localhost and then the port 555. Oops, our application is not yet running. Let's check why is that happening. Maybe we have other other Docker applications running there. So running Docker PS will give me all the running applications inside my machine. Let's try again, maybe it's the cache. And yes, my container is still running. It's the one that I have already created now and should be available on the port number 555. Okay, let me try to get this from this address instead of localhost. Yes, okay. Now it's displaying welcome to, and here is my application. It was actually the cache on my machine. So this is my application, my ASP.NET Core application. It's a web application displaying some pages about contact, the same as we have seen that the one that I have run it from my machine directly. Cool. Now we have created the image for the application. So this is now running my application. But what about the products here? I want to access the database to get the list of the products. Here we cannot access the database. Why is that? Because I cannot, because I didn't configure my database to run with this containerized application. Okay. So now we'll move to the second part where we'll add the database to our containers. So we'll try to run a container or to run the database inside a container and connect it to our web application. Before moving to that part, let me know if you have any questions regarding the Dockerfile.
Hi, Houssem. We had a question from Omar earlier. Does the Docker container need a separate kernel to load and launch the web app, or it can use the kernel resources from the host OS to run the app?
Yeah, so when you install Docker in your machine, actually you will have the two modes here. If you see here, you can run it, you can set it to run either Linux containers, or which is my case here, or you can switch to use Windows containers. And for both configuration, it's Docker who will configure it for you, so you don't need to worry about that. Okay. Any more questions? Good. I see only one question. Good. Now let's move to the second part. So here where we want to connect to our database. So here we have actually two options. Either we run the database inside the container, or we run it as another just standalone application. And for this demo, I'll show you how to run that application from, or to run the database inside a Docker container. So this means here I need to create another Docker container, and I need to create another Docker file for that container. And then each time I want to start my application, I need to start the two containers using two commands for Docker run the web app and then Docker run the database. And let's imagine now the scenarios where we have microservices with dozens or hundreds of applications. I want to run that Docker run command 100 times. So what will be the solution, or an elegant solution for this problem, is to use the Docker Compose. So what is the Docker Compose? I'll show you a sample Docker Compose file here. The Docker Compose, as its name suggests, it's enabled the composition of multiple Docker containers. So here I have multiple services. I have first service called web, which will run my MVC, my .NET Core application. And then I have a second server, which will run another container, which will be the container for the SQL server running inside the container. Okay, and because now I need to worry about the connection string for my database, and I need to configure the password and so on. So I can do all this configuration from the Docker Compose. Let's see here what is the configuration we have. Let me close this. So here, first of all, we are setting the port number for the first container, okay? Because at first, when we run the Docker run, we configured this on the Docker run command. Now we can do this also from the Docker Compose. Then for the database, we are configuring the database by exposing the port number, doing the mapping on 1433, which is the default port number for SQL Server. Then it's a database, so we need to give it a password. That's what we are doing here. And then we need to accept the EULA. So we are saying Y to say yes. And my web app needs to connect to my database. Let me show you one thing and the source code for this app. So my app needs to connect to the database, and we are configuring that on the app settings.json. So from here, we have the value for the connection string. And you note here, it's trying to connect to a local database. It means it will look for that database inside my machine or inside that container. And the database is not inside the container. It will be inside another container, maybe on the same machine, but it's sure that it will be in the same in the same network. So we need to give it the path or the IP address for that database. And here, note what we are using. We are using the alias DB. What that is, that's actually the name of the service that points to the database. And this is like, so we are not using the IP addresses here. We are using the service name, because the IP address might change, but the service name, it will never change. Docker will make sure that it won't change for your database. And Docker will map that service name to the IP address. So this way, we can configure here the new connection string by setting an environment variable, and we'll tell our application to take, when it runs, it should take this new connection string, okay? So it will use this value. This way, it will know how to connect to my database. Cool. So now let's see how to run this Docker Compose file. I'll go back to the command line. Let's clear this, and let me first, I have already container running, so let me stop it so it won't don't alter the new container that it will run. So how to do that? Docker stop, then the ID of my container. Okay, let's run that. It's now stopped. Let's run Docker PS to make sure it's really stopped. Yes, it's stopped. Good. Now let's move back to the parent folder where we have the parent project and where we have the docker compose.yaml file. Okay. Now to run that Docker file, we need to run the command docker-compose build. Okay. Using this command, this way Docker will take the Docker compose, it will run the instructions and there, and you see here it's already running the same instructions that will run the Docker file. So at first it will try to create the container for my application. That's what it is doing here. It will run all those instructions inside my Docker file because I told it to do so. here in the build. So I'm telling it to run the Docker file that lives inside the MVC app folder. Great, that ran successfully. And so it managed to create the container for my web app and for my database. Now let's go to start this Docker compose. So I'll use the same command, but not with build. This time it's going to be Docker compose app. So here you see it is detected the two containers for my web app and for my MySQL database. It started both containers. They are starting. Now all of this, what you see here is the initialization for my database container. And now my app is actually running. The two containers are running. Let's check that. Let's open a new window, and from here, I run the command docker ps to see the running container right now. And from here, we should see that we have 3, 2, 1, go. Yes, now we can see we have actually two containers running there. We have the container for my web app and the container that runs my SQL server, my SQL database. Good. And now I can access my application through the port number 8008. So I copy that port number, go to my browser, go to localhost to the port number 8008. And here it is, my application running inside the container. I can access the same pages and I can go to the products window. And now my app is connecting to my database and it is retrieving a list of products. Okay. Cool. So that marks the end of my second part for this demo. Let me know if you have any questions.
We have a lot of questions.
Cool,
So under
questions.
the published questions, there is a question on if we can containerize Docker app. Can it connect to a normal database that is not in a container?
Yes, absolutely. You can do that. And I'll actually discuss this later. And that's actually the best practice to do. Okay, especially when you run your containers on the cloud. It's okay that your application runs inside the containers, but the database, it's better to run it on a PaaS service on the cloud. You use something like SQL Azure to run your database. Why? Mainly for the SLA that you get with a database on the cloud, because you know Microsoft Azure, the team have been developing the PaaS services since, let's say, 10 years now. So they have achieved a high level of availability, of reliability, and they have included lots of cool features like managing the backup, managing the resiliency, and lots of good features that makes it ahead of, let's say, ahead of time when compared to a database hosted on a simple container. Okay, because the problem with that might happen with containers is that you should design your application for the fact that containers are ephemeral. And each time they can restart, okay? They can crash. And it's okay for the application to restart because you might have multiple containers. If one of them restarts, it's okay. The other containers can still manage the load and the user requests. But if the database crashes, that's not good. This means your application will stop responding. So here, what we are seeing people doing is that typically they deploy the application in containers, and they still use a PaaS service for the SQL database. Okay. Now this is true for most of the cases. This is true for, let's say, more than 90% of the cases. There are some special cases where we can use databases in systems like Kubernetes. For example, with MySQL, and MySQL databases, they have come out with this solution for creating a cluster of containers. The cluster will orchestrate how those different MySQL containers works together. So there is this architecture of a master that can control multiple worker nodes in order to have a high SLA, or in order to have a good reliability on this small cluster inside Kubernetes. And that project is called Vitesse, by the way, if you want to take a look at that. And again, this will mean that now you have a cluster of SQL databases that requires lots of knowledge, lots of you need a team to manage that cluster. So as I said, more than 90% of the projects, they use a PaaS service for their databases. That's the safest way today. I hope that answers your question.
All right, we got more questions as well. There is a question on the difference between Docker Compose, Docker Swarm, and K8s.
Yes, Kubernetes. Yeah, yeah. So let's be clear here. So Docker Compose, the one that I'm demoed here, is typically used to test the containers on your local machine. Okay, this is not planned to run in production. Most people doesn't use it in production. Okay. Because it's simple to configure, so it runs fast on your machine. And then comparing that to Kubernetes, Kubernetes is a cluster. Okay, it's multiple VMs working together. You can have a simulated version of that cluster running on your machine using the project Minikube. Okay, let me write that down maybe. If you are interested to look on that, I'm writing that on the chat window. So the project Minikube will install like a virtual machine on your machine, and on that virtual machine, it will run the whole cluster inside one virtual machine. Okay, so that virtual machine will take the role of the master and the worker nodes. And again, that's only useful for testing and development purposes on your own machine. To run containers on a production environment, there will be using Kubernetes, which is my next step for this demo.
There are a couple of more questions. So there is a question saying, what do we mean by using volume in Docker Compose?
Yeah, good question. Yeah, so in this Docker Compose, actually, I didn't specify any volume. What this means? This means the database that I have access to, that have this data, is hosted inside the container itself. And this is bad. If you tell an IT administrator, he will not be happy for that. Okay, because we should never let the database live inside the container, because as we said, the container might crash, I might lose that container, and if I lose it, I might lose my database. So what we do here is that we should use again PaaS services to save those databases. So we can either use the disk attached to the virtual machine that is attached to your cluster to save in there the database. So then when the container restarts, the database is already not inside the container, but it's living inside the disk attached to your VM. So the database will still there. And when a new container replaces that old container, it will connect to that old database. Okay, so I'm here So absolutely, we can attach a volume to your Docker and your Docker Compose. But here I'm not doing that, just to keep this simple. Okay, but you definitely can do that.
Another questions from the viewers: is there a way to get sensitive information like passwords into the Compose file, say from a key vault, to avoid storing passwords and connection string in the source control?
Yes, absolutely. So you can do the best way to do this is, of course, from your CI/CD pipelines. Typically, from your CD pipeline, you would connect to your Azure Key Vault or to your HashiCorp Vault, whatever you use to retrieve your secrets, your private certificates, your connection strings. You retrieve this value and then you go to replace it or to insert it in your Docker Compose or in your Kubernetes manifest files.
Three more questions to cover.
Yeah.
What's the difference between Ansible and Kubernetes?
Yeah, Ansible is a technology to provision and configure services. Okay, let's say it can create the Kubernetes cluster for you. Okay, not exactly that, but it can create those type of resources. Kubernetes is used to deploy applications onto. Okay, so I cannot say, for example, I will deploy my container on Ansible, because Ansible is like, let's say, Terraform. We can compare it also to Iron templates. It will provision those resources. Kubernetes, it will run my applications.
All right, we got a couple of questions from Hamad. So if using Docker Compose isn't the best practice, so would it be better to use different Docker files? And he also asked if there are any recommended courses related to Docker on the free Plural site.
Yes. Okay, so for the courses, I have already a course on Udemy. You can check that. It's a free course about Kubernetes. So it have the sections for how to create the containers, how to configure the persistent volumes, how to create the Docker Compose and run the app on Kubernetes. Okay. On Plural site, of course, there is some courses, and yeah, it's good to know that Plural site for all the month of April now, they are providing all their courses for free. So go check that out. And for the second part of your question, so we'll use Docker Compose on our local machines, and then we can use the native Kubernetes manifest files to deploy into Kubernetes. That's my next demo. Wait for it.
All right, we'll take one more question and then we continue with the next session. The question from Hatem says, he says, I'm using Ansible to provision my AKS cluster. Is Ansible better than Terraform?
It's not the way for saying it's better or not, but there is some small stuff where Ansible is recommended more than Terraform, and there is some other stuff where Terraform is recommended more than this. To create the Kubernetes cluster, and especially on a cloud provider, I would recommend to use Terraform. That's, let's say, it's becoming like the standard way for deploying infrastructure on the cloud. And I'll show you later some Terraform script for how to create your cluster and configure it. Cool.
All right, I think that's it for the questions for now.
Cool. So let's continue. So now that we have created the container and it's running in our machine, now we want to deploy this container into Kubernetes. Okay, that's why we have this this meetup. So to do that, first of all, I need to create the Kubernetes, or I need actually to to publish my container into a Docker registry. Okay, why? Because later for Kubernetes to retrieve that image, it won't retrieve that image from my local machine. It won't connect to my local machine. My local machine might be not working or off or so on. So I'll put my image to be available 24/24 for my Kubernetes cluster to be able to pull that image from there at any time. So let's, first of all, I need to have the container registry created. That's what I already have created on Azure. So if you go to right here in Azure, by the way, if you don't yet have an Azure account, you can create a free account. If you go to azure.com/free, you can start for free. And here I have already created a container registry, but let me show you how to create that registry. So I go to create a resource, and from here I look for registry. And there I have the container registry. I'll go to say I want to create this resource, and then I need to configure this these parameters and this template. So first of all, my subscription, then I need to specify a resource group. Let's go, I want to start with a new resource group. Let's call that Reactor Dhabi. And then a name for that resource group. So let's say again, I call it Reactor Abu Dhabi. That's Reactor. Yes, that's available. And then we can choose the location because Azure is a cloud provider. So we have data centers almost all over the world. And here you can choose where to host your service. The typical good practice to choose the data center here is to choose the data center that is the nearest one to your customers to have low latency regarding the network latency. So we can choose here, for example, West US. And I know there is a new data center in Dubai, not available from here. Maybe it's called the UAE. Yes, here it is in UAE North. Okay, good. We'll select that. Then for the admin user, I'll enable that feature to be able to connect to my registry. Then for the SKU, this defines what is the offering for your container registry. I'll select basic. And then I'm ready here to create my ACR. So once it passes the validation, now I can go to create my resource. Okay. I have already created one before, so I'll use that one, which is available on ACR sec. So here I have the information about my ACR. What I want to achieve now is that I want to deploy my container or to host my container inside this ACR. So I need to connect to it, and I need to get the password to connect to my ACR. So how can I do that? From here, I go to access keys. When you go there, you will see the registry name, login server, admin user, and username. Okay. So to connect, you would use the command ACR command. Let's stop this Docker Compose file, clear this out. And then we can use ACR login, the name of the ACR here. In my case, it's called ACR sec. And to specify the name, you need to use -n, then -u to specify the username, which is, in my case here, the registry name, again, ACR sec, -p, and here we paste the password, which is this one here. Hit enter, and then we should be able to connect to the ACR. Here, of course, I'm using the AZ command line, which is the command line to connect to Azure. I have downloaded that from Microsoft.com. And then I'm connected to my Azure subscription using the command az login. Okay, I have provided my login and password, and then az could log me into my container, to my registry. Great. Let's now try to push our container into ACR. So to do that, I'll use the command docker push. Okay, I have already prepared the command for that. Do not see me typing. So docker push, then the name of the container we created before. And note here where I'm tagging my image with the name of my ACR registry. Okay. This is mandatory for when you work with Azure Container Registry. So now Docker is trying to push all the layers into my ACR. It's loading those different files. This will take a few seconds, so that will be the right time. Any questions?
Yeah, we have questions from the community that came. I published them. So we have a question from Marwan, and he says, if we're deploying the app in the IIS server, can we use Docker with it?
Mm-hmm. So it means you'll need to run it. On IIS. And it runs only on Windows system. And containers, by default, they were created to run on Linux systems. That's why we call them Linux containers. Okay, but Microsoft have created containers, Windows containers that can run on Windows operating system. Okay, that's why we have here this option when you go to Docker. Doing that, as we have first the option to switch to switch to Windows containers. That's why you have this option here to be able to run those Windows containers. Windows container means you can install IIS inside that Windows container. Okay, so that's the way to do that.
There's another question as well. Is it possible to use the external registry like GitLab private registry? What should I do to enable the connection between the Kubernetes and the GitLab registry?
Yes, so for the registries, here I have used Azure Container Registry, but we could also use Docker Hub Registry. Okay, and you can also use GitHub Registry, or we can also use GitLab registry. Okay, all the registries or the Docker registries works almost the same way. Okay, and it's the same way how to connect to those registries using the Docker login. You can connect to those different registries with login passwords. A sample for Docker Hub for how to create those registries with some images hosted on Docker Hub. Okay. Now for the connection part between the two, in Kubernetes, we can connect to almost any registry, any Docker registry. We have configuration on the YAML file, on the deployment file, that will, in which will provide the login and password for that registry with the server, Okay. Let me know if there is any more questions while it's still uploading.
There's one, I'm not sure if it's a question or not. Azure has two CLIs, Azure RM, which is the old one, and AZ, the cross-platform one.
Yes, we do have to forget about the Azure RM. That's the old one. That's now from the past. What we recommend to use now is command line. Okay. I think this will take longer than expected, so I stop it and for published a registry before starting demo. So if I go to the repository in the menu here, I can see my containers that I have deployed before. Display in a few seconds. Yes, here it is. Now we can see the image that I have uploaded before. So I have called it MVC app. If I click on it, I'll be able to see the different tags that I have created. So I have created it with the tag. Cool. Now our image is on the registry. Now I want to deploy my application on Kubernetes using AKS service, Azure Kubernetes service. So first of all, I need to create the cluster in Azure. To do that, I'll go to the Azure portal, and from here I can go to add a new resource, and here I have Kubernetes service. I'll select that service, and then Azure will help me to configure the service. So first of all, I choose the subscription, the resource group, and then the name for my cluster. So let's say this is again Reactor Abu Dhabi, and then the region. Then I can choose the Kubernetes version, and Kubernetes will release a version each like 3 to 6 months. So I choose the latest available, which is in preview, by the way, 1.17. And from here, because Kubernetes is a cluster, it's a collection of virtual machines. In Azure, I can select or I can choose what is the configuration of those virtual machines. So if I go to change here, we have those different virtual machines available. They have different amount of RAM, CPU, networking capabilities, disk sizes, and so on. And I can choose what is the best VM for me. By default, we give you this standard DS2 V2 VM, and you can also control the number of those virtual machines in your cluster. So you can go from 1 VM up to 100 VM if you want to. For me, I'll stay reasonable and I'll select only 3 virtual machines. So that's the configuration for the VMs and number of VMs. Now I can actually mix and match between different virtual machines using different virtual machine sizes. Okay, so I can add another node pools that contains a collection of other virtual machines that might have different CPU, different RAM sizes, and so on. So I can mix and match between multiple VMs. Then for the authentication, it's here where we can enable or disable airbag. Airbag is what stands for role-based access control. That's what we use in order to give developers or IT team the right access to manage the Kubernetes cluster. So we can give the developers, for example, read-only access, and we can give the IT team the access to do read and write, for example. For the networking configuration, here we can customize some of the networking features. For example, I can use a network policy with Azure or Calico. This will enable me to set, let's say, like the firewall rules inside my applications running inside Kubernetes. So I can say my container A can talk to my container B, but it cannot talk to my container C because it's not supposed to connect to my container C. And that's a security feature we offer in Kubernetes to make your applications stay secure and connect to only the container that it should connect to. So if any of your containers gets altered or gets hacked, it will not be able to connect to the other containers. Additional settings are for integration. So here you can enable integration with your container registry if you have already created one. And that's all you need actually to create the Kubernetes cluster. From here, you can go to create. And once that's validated, you can click on the create button. The creation takes something between 5 to 6, 7 minutes, depending on your configuration. I have already created a Kubernetes cluster for this demo. So if I come back to my resource group here, you can find my AKS Kubernetes cluster. And here on this window, I have the general information about the version of my Kubernetes cluster, and I can from here go to upgrade my cluster, select the node pools, scale my cluster, and so on. So first operation I need to do here is to connect to my Kubernetes cluster. How to do that? Here we give commands that will be displayed here. So first of all, we tell you need to have a command line installed with the kubectl, which is the Kubernetes command line interface. And then you need to get the credentials from Azure to connect to your cluster. So here we give it the name of the cluster, the name of the resource group, and we tell it to get credentials. Okay, that's what I have already run it before, but let me tell you how that works. Let me show you how that works. So run that command, AZAKS get credentials, the name of your resource group, and the name of your cluster. And what that will do, that will download information about that, how to connect, and it will put it inside a folder or a file called kubeconfig. Okay. Then later you can do AZAKS browse if you want to access the Kubernetes dashboard. Okay. For now, I believe it's still. By the way, it's bad practice to use the Kubernetes dashboard unless you use it for development purposes. And here on Azure, by default, we disable it. Okay, you can enable it if you want to, but it's not good to use it, especially in production clusters. Yeah, the recommended way is to use the kubectl command line. Great. So now I'm connected to my cluster, and I can run the command kubectl get nodes to check what are the nodes attached to my cluster. So we'll see here we'll get actually only one node because I've configured my cluster to run only one node. I don't want to pay for 3 nodes while I'm not using them. And here we see our node or our virtual machine running inside the cluster. Great. Now let's see how to deploy application into Kubernetes. For that, I'll switch back to VS Code, and here I'll switch the folder, and I'll go to the Kubernetes folder. And here we have the different objects to deploy into Kubernetes. Before deeping dive inside those files, I want to explain one thing about Kubernetes, actually 2 stuff. So let me switch to my OneNote, and here, first of all, I'll just say one word about the Kubernetes architecture. So we said that Kubernetes at the end is virtual machines. Okay, so we have VM, another VM, and maybe a third VM, and we might have multiple virtual machines. Those virtual machines, it's in here where we run our containers, okay? Those VMs are managed by the API server, okay? So on top of those, we have what we call the API server component. This is the worker, or this is the master node, okay? All the other VMs are the worker nodes. This one is what controls those different virtual machines. So in Azure, when we did have the option to choose the number of the virtual machines, is the number of the worker virtual machines, what is in blue. The API server will be managed by Azure because it's a managed cluster. So it's up to Azure to make sure that this component will stay always working with high availability and all the good features coming from the cloud. You only manage the virtual machines. Okay. So now when I want to deploy applications into this cluster, we'll have, of course, it's the developer who will do that. Is a happy developer. He will write those configuration files. Okay, those are the YAML files that we'll see later. And in those files, he will put the link for his image. He will say, I want to run 5 instances of this image, for example. And then he will send that file using kubectl, kubectl. The API server will get that YAML file, will read it, and it will try to deploy the 5 containers inside my cluster. It's 5. This is the magical number here. So it will need to check the first VM. It will ask it how many, what is the amount of available space here. And it will do that through using the kubelet. The kubelet is a component installed on each of those VMs to provide those useful information for the API server. So the kubelet will tell it, hey, I have here 8 gigabytes available on this VM. So that would be enough to run 1 container, for example. On the second machine, maybe I have enough space to run 2 containers, and the same on the third machine. And then for my users to connect to this cluster, they will not connect directly to the virtual machine, but they should actually go through, they will need to connect to load balancer. So the load balancer is what sits between my happy users and my applications. So the load balancer using the service will know how to access those containers or those pods. So this is a quick overview about the Kubernetes architecture. Now let's move to another part where here I'll explain actually the content. I'll focus on the content of this YAML file. Actually, those are YAML file with lots of configuration. So let's say here, in my case, I want to deploy a web app, and I want also I want that web app to connect to a database. Okay. So I have a container that runs my web app, and the other container that will run my database. In Kubernetes, we deploy containers inside a pod. Okay, so the container should live inside the pod, not inside the virtual machine itself. So the pod is what will contain my my container. So here it will be englobed inside a pod, and the same for the database. It will live inside a pod. So now my web app needs to connect to that database. So it needs to know the connection string for that database. Okay, the connection string. So as we said, that might change. So we'll be using the service in order to retrieve the right IP address for that database. And the service here will sit on front of that pod. So this is the DB service, which will know how to connect to that database back and forward. And that's now for my web app to connect to the database, it needs to connect for the DB service. So it will reach the DB service. But the DB service, it have a name, okay? So from where to retrieve that name, and it have also information about the connection string for the database. So we want to save all the connection string. And here, I know one of you have already asked this question, but here where we can use another type of objects in Kubernetes, which is called the secret. So what the secret is useful for? Let me draw that here. The secret is meant to be an object that can store sensitive data like passwords, private certificates, and so on. So here I go to save my connection string, the value for my connection string, so that the web app will connect to that secret. This is first operation. It will get that connection string, then it will use it to connect to my database. Okay. So the secrets are meant to be secret, but they are not really secret because it's just the plain text value encoded in base 64. So it's better here to use other PaaS services like Azure Key Vault or Azure Vault or whatever. Good. And as an alternative to using secrets, we know we can use also the config map if we don't need to secure the data we have. If we have only just key value and we don't care about security, you can use another type of object, call it config map. Cool. So now my web app can connect to the database and it gets the data. Another question now here that comes around is, where is the database file? So we have explained it before that the database file should never live inside the container itself, but it should be outside my container. Where outside? It could be actually inside a disk, an Azure disk. So how we can create this Azure disk? Kubernetes API can talk to the Azure provider, and it can do that actually through using a Kubernetes object called the persistent volume. Okay, persistent volume and persistent volume claims. Those are the objects that will connect to the Azure API and ask Azure to provision an Azure disk that will be used by Kubernetes cluster to save this database file. So then later when that container crashes, when the database container crashes, the database will still, because it's outside the container, so it will persist in that persistent volume. Great. So now the missing part is how my users can connect to this application. Let's add that component here. So now my users, again, happy users, we hope, they will use their browsers or their mobile application to connect to the web application. And as we said, they cannot reach that the pod directly, but they should actually pass through the service, okay, or the load balancer before. Actually, they will reach a load balancer, and the load balancer will use the service to connect to the right pod. Okay, so this means here I'll use a second service for my app. Let's call this the app service. That will reach my pod and get the response from there. So those are the typical architecture for web and database application that runs on Kubernetes. Okay, now let's see the files, the YAML manifest files for creating those different objects in Kubernetes. Okay, when we deploy an application in Kubernetes, it's not just deploying the containers themselves, but we need to care about the secrets, configurations, the persistent volume, config map, I mean, persistent volumes, load balancers, and so on. So let's see how this configuration looks like. So let me start here with the deployment file for to deploy the web app. Okay, so here this deployment file contains lots of metadata to identify this deployment, and the important section is here, the containers. Here where we want to create to host the containers inside the pod. Okay, so we need to provide a name for that container, obviously. Then we need to put the source to get that container. And here, note, I'm using the same container image that I have specified in my registry. That's not actually the same one, but I need to use the same image, MVC-app. So this means here I need to change this to MVC-app and the tag 1.0, which is the same tag I have available on my Azure ACR. Great. Then I expose the port number 80. Then, because this will run inside the virtual machine, so I can specify that I can tell it that this container should not exceed consuming 200 megabytes on memory, and it should not go beyond using one CPU, for example. And then this application needs to get the connection string. So how to do that? Here, I have provided the value for the connection string inside the config map. So here I'm telling the name of the config map and the key inside that config map. My config map is called MS-SQL connection config map, which is a file available here with this name and with the value, with the name and value for my connection string. So note here, the value for my connection string is using server equal MS-SQL service. This should be actually the IP address or how to retrieve the SQL server database. So I'm using here MS-SQL service. This is the service name. This means we have a service called MS-SQL service. That's available on the file MS-SQL deployment, where here on the bottom we have the service for the database called MS-SQL service. Okay, and yeah, then we'll use. Let's come back to the app deployment. So that way we specify the environment variables. Okay, to connect to the database. My users needs to connect to this app. They will need to go through a service. So that's why here I have a second service for the to connect to the app, and that's here using the load balancer. I'm using load balancer here to be able to provide a public IP address for my end users. Then, of course, I can map this IP address into a domain name, for example, public domain name. Cool. Back to this MS-SQL deployment file. And this is the how to deploy the container for my MySQL instance. Okay, so here I'm providing again the path from where to get the image, the resource limits, the password for my database, and here I put it in plain text just for the demo, but never do that. As I said, you can configure your passwords and key vault. And then to save the database in the Azure disk, I'm using this volume mounts. So what I'm saying here is that I should use this volume to save my database. This is the path will be on an Azure disk because they have tell it here to use a volume, which is a persistent volume claim with this name, MS-SQL PVC. And that's the file that I have configured here. So this will talk to Azure API because I have specified here the provisioner to be Azure. API, Azure Disk, to create an Azure Disk with the offer standard. That would be a managed disk. And then I can configure that disk to have a size of 1 GB. Okay. Then I can connect to that disk and I can save my database on that disk. Good. Now let's try to deploy this application or those YAML files. So I need to go to my Kubernetes folder because there where I have those different files. Make sure I have those files available. Great. And from here, I run the command kubectl apply, or I can also use create -f, and then I specify the folder that contains all those files. So I specify the folder to deploy all the files inside. Run that command, and now Kubernetes will receive my YAML files, will read them, to understand that I want to create 2 containers for my web app and for the database. It will create those containers for me, those pods actually, and it will pull the it will pull those images from ACR. And there, one of the questions was about how Kubernetes can connect to my registry. So as I said, we can add a configuration in my MS SQL deployment here, where I say, where I put here the login and password for my registry. But what I have done here with AKS is that I have attached my ACR into Kubernetes. And I can provide you with the link here that I have used to enable that integration. I'll add that as announcement. I put that link, and yeah. So here I have this simple command, az AKS update, and here I'm using attach ACR. So this means Kubernetes will be authenticated to my Azure Container Registry. So it doesn't need the login and password. When it tries to connect, ACR won't stop it to tell it, give me the login and password. It will be authenticated, and the connection will be secured because both resources lives in Azure backbone or in Azure data centers. So with this way, I don't need to provide login and password. That's what I have used. So I have run that command before this demo actually. Yeah. So let's see now where is our deployment file. So you see here the status is created. So we can check now kubectl get pods because we have deployed pods. So you see here our pods are trying to start, and here I have an error on one of my pods. Let's see why is that. I have copied the right image name and image tag. That should be the same one that I have used in my ACR. If that's wrong, I won't be able to connect. Good. Maybe it's time to ask some questions while I try to fix this. So attach ACR, let's call it ACR sec, and my resource group. The name of my cluster, AKS Kubernetes, then the resource group. Let's see here. Okay, you know what? This won't work actually, because I believe these 2 resources should be inside the same resource group. So as a quick fix, I'll point out here to another image hosted on Docker Hub. Okay, so instead of using this one, I comment it out and use another image available on my Docker Hub registry. Okay, so it's as simple as that to switch between containers. So again, I run the command kubectl apply, and here You see now it's configured while all the other resources are still same. So now try to get the pods, and here our pod is running. Good. We can also check for the other resources. So now we want to access this application. So we run the command kubectl get services. Get services will give us all the services that we have created, the MS SQL service and the MVC service. And you can see here it's available under behind an external IP address. So I can get this external IP address. Let's try to access my application that is now running in a container inside the pod in Kubernetes hosted on Azure. And here, yeah, my application is now live. So I can go to click products, and here my application is supposed to connect to my database hosted on another pod where the database is hosted on an Azure disk. And here it is. Now I'm able to connect, and I can go to create a new product, let's say like the Xbox, and create that product, and it was added right here. Great. So that's how we was able to deploy our application in Kubernetes. I want to finish with one thing here before taking your questions. So in the on Azure portal, I have showed you how, the Kubernetes cluster, how to manage it, and so on. But it's also worth mentioning that with that resource group, there is another resource group that was created automatically for me that contains the the virtual machines, the virtual networks, and so on. All the resources that runs my cluster. It's a cluster. We have multiple virtual machines. Those virtual machines need to connect to each other. For that, they will be using the virtual network, and they need also to use an ASG to use route table to be able to connect to each others. And I need to provision also a load balancer to provide a public IP address for my users. And you see here the disk that was provisioned by my Kubernetes cluster API. Okay, so those are the different resources that runs your cluster, and we give you access to those resources if you want to customize them. Cool, that was the end of my demo. I hope you like it. And yeah, I think now it's time to take your questions.
Thank you so much, Houssem, for the session. And we got so many questions coming in during the demo. There was a question from the latest saying that what is the best practice to handle multiple environments, to use Kubernetes cluster for every environment, or use one cluster with nodes labeled for each environment?
Yes, good question. The short answer is that to creating multiple environments, we can use two approaches. First approach is to use the namespace, okay, which provides a logical separation between the resources. Okay, this means we can create a namespace for dev environment and a namespace for a production environment. But the problem with this approach is that you know, the containers in your dev environments and your production environment, they still use the same resources behind. They use the same virtual machines. And this means if your application and dev environment eats lots of resources suddenly, this means your production containers, they won't have enough resources, and maybe they will crash and restart. So you can do that to use the namespace for logical separation, but that's not enough for production environment. You can use that to separate between, let's say, your dev and test environment, or your dev 1 and dev 2, but not definitely use that with the production applications. So for that, we have the second option, which is to use the physical separation. And here we mean to create multiple clusters. So what customers do is that they they will have a production cluster, and there they will run only the application with configuration for the production environment, and they will apply the least access privileges. It means less people will have access to that cluster because its production is dangerous and we don't want anyone to be able to touch to that cluster. And for testing purposes, for the other environments, dev, test, QA, UAT, you name it, we'll have other clusters dedicated for those environments. So at the end, you can say a cluster for dev, cluster for test, and a cluster for production. So that way you can give your developers or your development team the ability to test how the application works on Kubernetes, to give them enough freedom to test new things and help them to master how Kubernetes works. Any more questions?
Yeah, we have so many questions. I think we should schedule another session as well to cover more and to cover more of the questions and more of the Kubernetes as well. There is a question on the option to spread the environments like namespaces. Is there another option? The question says, is there any other option to spread environments like namespaces?
Mainly the two options are either to use the namespace or physical separation by using multiple clusters.
And what is the best practices for deploying databases on Kubernetes using a managed, like a Cosmos DB, for example?
Yes, so as I have already explained it, it's better to host your database inside a PaaS service in the cloud instead of a container inside your cluster. And there you have multiple options. So in Azure, for example, if I go here to create a new resource, if I try to look for databases, we'll have large selection of databases. You can use, as you said, Cosmos DB for NoSQL databases, but you can also use SQL Server, as I have used it today. You can use MySQL, MariaDB, and Postgres. Yeah. If you want to use cache, you have the option to use Redis cache. So multiple options are available on Azure. So at the end, put your application, your container application inside Kubernetes cluster, and for the database, just use a PaaS service.
There's a question saying, what's the microservices best practices on Kubernetes? Deploy, architect, and monitor.
Yeah, I'll give you a link, eShop on containers. You should know about that application, eShop on containers. It's this link here. I'll paste this on the announcements in the chat window. Done. So this is a GitHub repository created by Microsoft, by a team that works on Microsoft, and their goal was to create, let's say, a solution, a microservice application that respects the best practices for how to deploy applications on Azure and using containers on Azure Kubernetes service. So it's we can see here the architecture of that application. So we can see we have multiple microservices, ordering, catalog, identity, and so on. And those microservices will connect to PaaS services, as we see here, Cosmos, SQL Server, and so on. And they will use also other PaaS services like Message Bus or Service Bus, Azure Service Bus, eventID maybe, and so on. And you have multiple applications that can connect to the backend services, either through using an API management solutions like Azure API management or other third-party solutions. So this guide here have actually, this is what I wanted to show you, a book. They have written a book about that architecture with respect to all the microservices architecture and best practices, along with all approaches that comes with microservices. You know, DDD, CQRS, to use a backend for front-end services. Lots of concepts that we apply with microservices. So it's good to know how to develop microservices, but also good to know how to deploy those microservices on container solution like Kubernetes. So this book will have will answer all your questions about all those best practices.
One more question from the community. He says, when I create storage classes for provisioning storage in Kubernetes, how do I provide permission from my AKS into my storage account?
Yeah, right. Here I'll come back to the stuff that I have drawn here. And when I presented the Kubernetes architecture, I didn't mention one important stuff, is that here actually, when we have Azure here on the cloud, I don't draw the cloud. Good. Okay. The API server or the Kubernetes cluster actually can talk to the Azure API. Okay. To ask it to create, for example, the storage disk. Okay. Maybe to create the load balancer. To create also other many other resources. So all what you have already seen in my resource group that backs my the infrastructure for my Azure. Let's see. Let's come back. All those resources you have seen here were provided or were created by Kubernetes API. Okay. So you see here, one of them is the persistent volume claim. That's your storage account. Okay. And this was created by Kubernetes API. It have a component inside it that will talk to Kubernetes, that will talk to Azure to ask it to provision this one. And that's what we have done through the persistent volume claim, where this one here. This will talk to the Azure disk, and it will ask it to create a managed disk with capacity of 1 GB. So for the authentication, you don't need authentication. It will be handled by Kubernetes because Kubernetes lives inside Azure, so it's supposed to be to have the secure connection to connect to the Azure API. Any more questions?
I see more coming in. How to monitor health metrics, and yeah, is there a way they can contact you? How do they follow you? How do they find you online? I think we wrap up with these two questions, and we definitely need to set up a new time for another session to go even deeper and cover more of the aspects of this topic, since the community is very, very interested in this.
Yeah, thank you. I would like to schedule another session for Kubernetes. That's the subject I like, and I love to talk about Kubernetes. So yeah, for the question how to monitor the cluster. So here, let me show you first this tool. So from the command line, we can do kubectl top nodes, and this will give you simple data about the resource utilization of your node. So you see here it's using 8% of my CPU and 85% of memory. And you can do also kubectl get pods to get the utilization for each of your pods. So we'll see the amount of memory and CPU displayed in a moment. Yeah, here we see those information, 782 for my MySQL instance and just 54 megabytes for my web app. But this is not enough, okay? I know. So what you are looking for is more metrics about not only the pods and the virtual machines, but also metrics about the application, the request, the HTTP request and response times, and so on. So you can do that here in Azure. We can enable this feature for insights. So you can see in your cluster the health of your cluster, the health of the storage and database. So this is the basic information you get. Actually, I didn't activated this, but if you activate it, you will get more metrics available from the Azure dashboard. Okay, let's say it will give you a dashboard like this one where you can see the metrics and also you can get the logs for your cluster. If you want to implement that in your Kubernetes cluster, I have already written an article on Medium. Oops, it's Medium. I can send you the link here to put to find the different articles. So let me, yeah, here it is. How to monitor using Prometheus and Grafana. Okay, I'll send you the link there, and this will install Prometheus and Grafana in your cluster to be able to scrape the metrics and create a nice dashboard at the end to get all those metrics at the end of this one. Yeah, so you'll get a dashboard like this one where you have richer metrics about the health of your applications running in your cluster. Yeah, so you have the two options, either to use the integrated monitoring in Azure, because AKS is a managed cluster, so we provide a monitoring solution within Azure, and you can also use other open source third-party tools like Prometheus and Grafana to have those metrics and logs of from your cluster. Any more questions?
All right, I think the questions will keep coming. Let's wrap up, and we will definitely need to do one more session very soon. So stay tuned, everyone, for the coming session. Thank you so much, Houssem, for the session today. And I would definitely want the community who are still watching and will be watching also this recording of the session to reach out to us on meetup.com. Reactor Abu Dhabi, send us your ideas for the coming sessions, your interest, and we would love to know this. Also interact with us on social media, on Twitter, on the hashtag as well,
And
Reactor
my
Abu Dhabi. Yes, and definitely follow Houssem. So your account is?
On YouTube, just look for Houssem Dellai, my name, and you should find my channel.
Definitely.
Yeah.
And the link is also there in the meetup description of this event. Thank you, everyone, for watching and tuning in. Thank you, Houssem, for this amazing session. And we'll see you again very soon.
Yeah, thank you, Houssem, for having me in this nice tutorial about Kubernetes. So thank you, and see you next time.
All right. Bye-bye, everyone. See you soon.
Bye-bye.